Today, we're going to make a more advanced variation of our loading indicator. Let's go. Okay, so we're in the middle of a series of videos on creating procedural shapes and patterns using shaders in Unreal and Unity. Throughout the series, we've been building a library of subgraph nodes or material functions that we can connect together to create all sorts of effects. If you haven't been following along, I've linked the playlist for the whole series down in the description so you can catch up. And if you're just looking for how to make a specific subgraph node, there's a list of them in the description, along with a link to where I show how to make each of them. All right, last week we created this animated loading indicator. It's pretty cool looking, but we can make it even better. So today we're going to use some of the additional nodes in our library to add some improvements. We'll start out in Unity today, and then we'll switch over to Unreal and do the same thing there in a minute. All right, so first we're going to make the circles change size depending on where we are in the library, in the larger circle. So right now, all of these circles are the same size, and you can just see that their brightness is changing as we go around the circle. But what we want to do is change the size of the circles depending on where our indicator is going around. All right, so this is pretty simple. What we're going to do is grab this bit of this set of nodes here, and move them over just a little bit. What we have here is our circle node, and this is the node that's generating our circles. And here we have an input that's controlling their size. So right now I have the circle's size set to 0.4, and if I change this to something like 0.8, you can see the circles get bigger. So what I need to do is base the size of the circles on this mask that we're creating so that the circles get larger as the mask goes around. And what I want to do first is just adjust the values here just a little bit. So I'm going to add a linear interpolate node, or a lerp, and connect up my posterized mask here. And what we're going to do is lerp between negative 0.5 and 0.5, and this is going to control the size of our circles. So if we just grab the output of this lerp and wire it to the size of our circle, now you can see that we've got our circles going around, but it looks like they're backwards, right? Because they start out small and then get bigger, and I think we want it to do the opposite. In order to fix that, we can just set our lerp to, instead of negative 0.5 to 0.5, we can set it to 0.5 to negative 0.5. And now our circles start out big and get smaller as we go around. All right, this is looking pretty cool. That was the first effect or improvement that we wanted to make to our indicator. The next thing that we want to do is create some animated perspective. Right now, our circles just look like they're on a flat plane, but what we want to do next is create an illusion that this effect is actually happening in 3D space. And so we're going to use some perspective warping that we created a couple of weeks ago. And this is going to be pretty cool. All right, so we'll come over here to this part of our graph just to give ourselves a little bit more space. And we're going to work on our UV coordinates. So before we add the adjustments we're about to make to our circle indicator, what I want to do here is just make a checkerboard node. And this checkerboard is kind of going to be an indicator for what's coming. We're not actually going to use this in the final shader. I just want to use this checkerboard pattern to show you what's happening. So we want to alter our checkerboard pattern and perspective warp it. And so we're going to add our perspective node that we created a couple of weeks ago. And like I said, down in the description, I've got a list of all of the nodes that we've created in the series so far. So if you didn't create this perspective node as you were following along and you want to know how to make it, just go down to the description and take a look at the link down there where it talks about how to make this, and it'll take you right to the location where we made the perspective node. Okay, now what we're going to do is take the UV coordinates from the perspective node that we've generated and plug them into our checkerboard. And right away you can see that now we've introduced this idea of depth to our checkerboard. We've kind of warped it, and it's kind of fading off into the distance to the side. Let's change the amount of skew that's happening. Actually, even cooler, instead of just making this skew static, let's animate it. I think that'll be really neat. So in order to animate this perspective warp that's happening, we're going to add the sine time node. And this is another node that we've created earlier. And again, I've linked it down in the description. We're going to set the speed to 1. And I'm going to grab the normalized time coming out of the sine time node and connect it to a lerp. We're going to adjust the range of values coming out of here. So sine time, you can see it's just kind of creating a wave pattern where we go white and then black, and then it actually goes into -1. So it's going white and then 0 and then -1 and back. And we're going to change that range. I'm going to switch it to -1 to 0. And then we're going to plug this into the skew amount that we're getting here. So I'll just plug this right into skew. And now you can see our checkerboard is doing this really cool animated perspective warping. And that's exactly what we're looking for. But we need to adjust it just a little bit before we're done. And so let's change the scale of our UV values. So right here in between our perspective warp and where we're using the UV coordinates, I'm going to create a UV scale node. And again, this is a node that we created previously in this series. I'll wire my perspective coordinates into that. And then for the scale, we're going to be adjusting the scale as we warp. So again, I'm going to grab the sine time node and adjust its range. We'll create a lerp node here, and we're going to make sine time. This time it's going to go from 0.5 to 0.8. And these are going to be my scale values. So as sine time goes, it's going to go back and forth between 0.5 and 0.8. And so we're going to use this for our scale amount. And now we can plug this into our checkerboard, and you can see that as we're scaling, we're also adjusting the size. And so that makes it look like we're kind of tilting the plane as we move things around. All right, the last thing that we want to do with our effect here is we want to move the UV coordinates. In addition to perspective warping and scaling them, we're going to move them. So I'm going to pull this wire out here, and we're going to type move, and we'll add our UV move node. And for this one, we're also going to be using our signed time. And so I'm just going to grab this here, and we're going to add another lerp so we can adjust the range. And this time we're going to go from a range of 0.12 to 0. We just want to move it just a little bit as we perspective warp it and scale it. So I'll plug this into our move and then use the UV coordinates coming out of here to plug into our checkerboard. Now I did make one mistake here. With our movement, I actually only want to move it on the x-axis. And so I'm going to add a new node here, a vector 2, and we're going to plug our animated values into the x-axis, but then the y-axis we're just going to leave at 0. And that way our movement is only on the horizontal. You can see how as we're animating back and forth here, it's kind of going vertically, and that's kind of weird. And so we want to keep it just moving horizontally and not vertically. All right, so now you can see what our UV coordinates are doing. We're warping and moving and scaling them, as we animate back and forth. And what this is going to do when we plug it in is it's going to make our loading indicator here look like it's in three-dimensional space. So instead of animating our checkerboard here, we're going to take our original UV coordinates and plug those into our perspective node here. And then we're going to do our perspective scale, our perspective warping, our scaling, and our moving. And instead of applying this to the checkerboard, we're going to take our result and apply it to our loading indicator over here. All right, so let's grab these nodes and move them over and take a look at our result. Okay, so now you can see as we watch this thing go around, we notice that it's warping and scaling and moving, and it makes it appear like it's in 3D space. And I really love this. It's super cool. All right, so what I wanted to show you today is that we can take a bunch of these nodes that we've used in our library. Last week we used scale and grid tiles and circle and anti-aliasing and linear time. And then this week we used the perspective and scale and move and sign time to take the effect even further. And with these nodes that we've been building in our library, it's really easy just to connect them up and get some really neat looking results. All right, thanks for watching. Now we're going to switch over and I'll show you how to do the same thing in Unreal. All right, here we are in Unreal. And just like we did in Unity, we're going to make a more advanced version of our circle loading indicator. So there are two features that we want to add to our circle loading indicator. We want to change the size of the circles based on where we are in the progress going around. And we also want to apply some animated warping to our effect so that it looks like there's some parallax or some 3D motion happening. So first, let's change the size of our circles based on where we are going around the larger circle. So here is the mask that we're creating. Let's see if we just preview this mask right here. Yeah, this is the animated mask that's controlling the progress around the larger circle. And right now we're just using it as a multiplier for the brightness of the circles. But what we can do instead is use it as the size. This node here, the circle node, is generating our circles, and it has a fixed size of 0.4. But what we can do is take this mask that we're generating, and let's go ahead and preview this node here. And I'm going to drag this out. I'm going to create a linear interpolate node. And we're going to interpolate between a value of 0.5 and negative 0.5. This is going to be the size of our circles. So as we're going around, we're going to be changing our circle size between 0.5 and negative 0.5. So if we connect this up to the circle size, now you can see that we've got our circles, kind of the leading circle going around is large, and then as we get further, the circles get smaller and smaller. So that's the effect that I was going for, and that looks great. All right, the next thing that we want to do is add kind of some perspective warping to this. So just like we did in Unity, I'm going to add a checkerboard here, and this is going to help us visualize what's happening with our UV coordinates before we actually apply them to our animated circle here. So I'm going to add the perspective node that we created previously, and this node will warp our UV coordinates so that there's some perspective applied to them. So I'm just going to take the output of perspective and connect it to the UVs of the checker pattern, and we'll preview this node here. And now you can see we've got our checkerboard, but it looks like it's warped. Let's just change the tiling here. Maybe set the tiling to maybe 16. Yeah, that's pretty cool. All right, so you can see here the UV coordinates, without this perspective warping here, if we just add some standard texture coordinates, our checkerboard pattern is going to look flat and two-dimensional. But with our perspective warp, we're able to tweak it out so that it looks like it's receding off into the distance there over to the left. All right, the next thing that we want to do is animate that effect so it feels like the perspective is shifting. And this is going to be really cool. So in order to do this, we need to add the sine time node. And this node is going to make time fluctuate between -1 and 1 if we're outputting from the raw. We're actually output from the normalized, which means we're going to be shifting back and forth between 0 and 1. So here you can see we're at 1, and then we shift back to 0. It's going kind of slow right now. Let's see if we can speed things up a little bit by setting speed to 1. There we go. All right, so now we're at 0, and then we shift back to 1, and then we shift back to 0. So this is the value that we want to use to change the skew amount of our perspective. But we want to adjust our sine time value just a little bit first. So I'm going to take the normalized value coming out of here, and we're going to add a linear interpolate node. And we're going to linear interpolate between a value of -1 and 0. And this is going to be the amount that we skew. So I'll plug this into our skew value here. And let's preview our checkerboard pattern again. All right, so now you can see we've got this cool looking animation happening here. And it's actually, it's happening in the opposite direction as it did in Unity. So I think maybe if we set this instead of -1, if we set this to 1, whoa, that didn't work. All right, well, let's just leave it as it is. That's fine. Okay, the next thing that we need to do is after we've done our perspective warp, we need to adjust the scale of our UV coordinates just a little bit. So I'm going to add the scale node. And once again, all the nodes that I'm adding that are in this procedural UV category or procedural category, these are all nodes that we've created previously in the series. And I've linked them down below so that you can jump to that point in the series if all you want to make is the one node. All right, so we're going to take the results coming out of sine time. And again, we're going to adjust the value range coming out of sine time. We're going to lerp between 0.5 and 0.8. And we'll plug this into the scale amount there. And then we'll plug that into our checker pattern. So now you can see that in addition to perspective warping, we're also scaling. So it feels like the plane is being tilted kind of along this center axis. And the last thing that we're going to do to our UV coordinates after we scale them is we're going to move them. So I'm going to drag out scale here, and we're going to add a move node. And again, we've created this node previously in the series. And the amount that we're going to be moving, we need to adjust our animated sine time again. So there's our sine time node. We're adding another linear interpolate node to that. And we're going to adjust this so that we're just moving it between 0.12 and 0. And we only want to do this on the x-axis, not the y. And so I'm going to add an append vector node. And we're going to set the x-axis to this animated value. But the y-axis, we're just going to leave at 0. And that's the amount we're going to move it. So we'll plug that into the move node. And then we'll connect up the output of the move node to our checker pattern. Cool. So now you can see that as we skew over here to the left, we're also moving it slightly to the left. All right, so I just want to clean up my graph a little bit here, kind of move these nodes up. And now what we can do is take this animated UV coordinate set of nodes here and use those as our incoming UVs for our animated loading indicator over here. So we're going to delete this. This checker pattern was only temporary, so we'll get rid of that. And then we're going to move these over and use them as the UVs that we're generating that are coming into our polar coordinate right there. So I'll plug the output of the move node into our polar coordinate, then come over here and we're going to preview the last node in our series here. So I'm going to pick start preview node. Yeah. Okay, and now we have some movement going on, but you can see that the movement is kind of clipping off of the screen here. So we need to use a little bit different values than we did in Unity in order to get this to work correctly. All right, I took a look at it and it actually turns out that there's just one small adjustment that we need to make. Instead of lerping between 0.12 and 0 here, we're going to actually move it in the opposite direction. We're going to set this value to negative 0.12 so that as we warp over here to the left, we move the UV coordinates to the right so that our pattern stays on the screen. But we're all done now. There you have it. We have our perspective warping happening here. You know, as our circle pattern is going around in circles, it's also skewing to the left and moving slightly to the right. So it makes this loading indicator look like it's happening in a three-dimensional space, which is a really cool effect. And what we've shown is that because we've been working this whole time to build up this library of these nodes that are built specifically for creating this type of effect, all we have to do is string these together, and it makes it really fast to create our effects. You know, we don't have to build these nodes every time that we want to make these effects. We already have our set of bricks, and we can just connect them up and create effects like this really quickly. I hope you're enjoying this series. This is something that's super fun for me to show, and I hope that you're following along and you enjoy watching it as well. If you have suggestions for what you'd like to see in terms of procedural shapes and patterns, let me know down in the comments. I'd love to hear what you guys are hoping that we create. I think next week we'll probably create a loading bar or maybe a health bar or some other kind of indicator like that that you can use as a user interface element on the screen. So come back next week for that. And in the meantime, have a great week, everybody.